All right, I can hear everybody's stomachs growling already, so we're going to go through this as quickly as possible. But this is probably the most forgotten part of a GC analysis when we're looking for problems, and that's the consumables end. So we're going to go ahead and go through this presentation. We're going to go ahead and talk a little bit about how different parts of the consumables products can help you do a better job in your analysis and keep you from having problems. So we're going to look a little bit at sample preparation, sample vials, syringes, liners, and columns. And first of all, you know, as you've heard earlier, sample preparation consistency is really important. So if you take out the human error, it's going to help you a lot. We have a couple of things to help you there. We have an Auto Trace 280 for large volume SPE, and we also have the rocket evaporator for blowing down your samples. Let's talk a little bit about sample vials. Some things that you can look for or problems that you can have are ghost peaks. Septic can block your syringe. You can get poor calibrations because of absorption onto the sides of the glass. You can have degradation, and you can also have evaporation if it doesn't seal properly. Ghost peaks. A lot of people change solvents when they're doing methods and developing new method applications. And one of the things they do is they always grab the same septa, and it may not be right for the solvent that you're using. So one of those things you need to check is to make sure that you're using the right septa on your sample vial. The other thing is blocking the syringe. What type of needle are you using? Are you coring this septa? Are you using a cone-shaped? So when you replace the syringe, make sure you use the same type you're using before. Poor calibrations. We found that we had pyrethroids sticking to the sides of one type of vial, and it didn't stick to the other. So you want to make sure that you don't have silanol groups on the side of the vial grabbing compounds. And you can see over here on the right-hand side the difference in the calibration curve on using two different types of vials. Sample degradation from light. We always talk about keeping them in the dark, using amber vials. But if you're just looking at UV degradation, glass cuts back on UV light. You know, you don't get a sunburn sitting in front of your window at home. Evaporation. If you take multiple injections out of the same vial because you're doing replicates, you need to make sure that you have a septa that will seal real well, especially if you do calibration curves 2 or 3 times. Texture limits can be lowered by using a different type of vial. Most 2 mil vials you can only inject if you have a volume of 100 microliters. And if you have less than 100 microliters, that means you have to transfer that sample into an insert. So now you've got twice as many products that you're using, twice the cost. Why not start with a vial where you can go ahead and you can evaporate it down in the vial to a volume of 0.25 microliters and inject that. And by doing that, you've now concentrated your sample down an extra 4 times. So use a high recovery vial if you're going to have a small amount of sample to inject. Liners. There's different types of liners for different types of methods. There's geometry. There's different types of liners for split and splitless injections. Different materials. We have glass, silica, silco steel. Do you want to use a packed or an unpacked column? And what about the diameter? How does that affect your analysis? The straight is a great, because it's cheap and it's great for split injections. Problem is that you have your sample come in contact with the rest of the inlet, and you can have a lot of low and high boiling discrimination. The gooseneck is for a splitless injection. Does a better job of getting your sample onto the column. But if you don't check to see your expansion volume of your solvent, you can get a lot of blowback, and it end up into your split line and into, that'll end up contaminating your next few samples. The next is a double goose. That's great because it cuts back on the blowback and it keeps your loss of volatile materials to a minimum. The problem with it is it's hard to clean and you can't pack it with wool or something. Also, there's pack columns. We have two different kinds. The ones that come already packed, or the kind that you can pack yourself with the wool. We have a double restriction. I don't know about you, but sometimes I forget what kind of liner I have in my instrument. And when I go to change the liner, and I take the top off, the glass wool comes popping out of it. That's great if you want to change the wool, but if that's not what you were going to do, then you got to repack that. And by having these two restrictions, it keeps the coarse wool in the liner. Also, it is deactivated inside the liner, so you don't have to worry about any contamination. Liner activity. How do you know when your liner is active? You can inject DDT or Endrin or both. Look for the breakdown products of DDD and DDE, or with Endrin, endrinaldehyde and endrin ketone. EPA says that you shouldn't have more than 15% of breakdown products. I say if you're getting close to 10, you need to think about changing your liner. This is what happens when you use the wrong liner. The bottom chromatogram is using a split liner with a splitless injection. And this is C8, C10, and C12. And you can see what happens to your first two compounds. And then going back and injecting with the correct liner, the splitless, you can see the nice peak shapes that you get. So it does make a difference. Now I want to talk a little bit about column choice. We're talking about stationary phase, polysiloxane. We're looking at functional groups, methyl, all the way to phenol. Makes a difference. So many people want to use a 5 ms column for everything they run. And that's really great when you're doing EPA methods like semi-volatiles, 8270, where you have 147 compounds that you're analyzing, and they're all different types of compounds in their mix. But if you're looking for a specific type of compound, you're looking for just phthalates, or you're looking for dioxins, pick a column that's specific because you'll get better results. Column length. A lot of people like to cut back on the column, on the length. Longer column gives you better resolution. The shorter column, you can get your compounds off in a shorter amount of time. If you can live with the resolution, that's great. But just doubling the column does not double the resolution. So always remember that. The internal diameter, how does that affect your results? Well, smaller diameter gives you better efficiency and better resolution, but it also decreases your capacity, and it's easier to overload the column. So it depends upon what you're looking for, what concentrations, what your matrix is. We refer to these smaller diameter columns as fast GC columns because of the improved resolution with the same runtime. Reduced runtime with similar resolution. Improved sample throughput. Everybody's looking to run more samples in the same amount of time. This next is an example of using a TG5MS column, a 10 meter column, 0.18 by 0.18. And as you can see, 209 comes off in less than 9 minutes. And all the other application notes and stuff that we could find, 209 came off in 13 minutes. So you're getting 4 minutes off of your run. And we still have resolution for the first groups of compounds coming off. This is with a 1 microliter injection and with a pre-column 0.53 millimeter. Film thickness. Heavier compounds tend to stick in your column. So if you're looking at heavier compounds, you need to use a thinner phase. Thinner film will give you sharper peaks. Also reduced column beam. Also a shorter column will give you a reduced column bleed. Improves your signal to noise because of the better resolution. And the analytes get to react with the wall a little more. Again, you got to remember that you have decreased analyte capacity. So you can overload the column very easy. Thicker film gives increased resolution for your lighter compounds. Worse resolution for your late eluting compounds. Gives you better elution temperature, better analyte capacity, and gives you better inertness. Here's a table summarizing this. There's one other thing I want to show you before we finish. Here is a table of phase ratio. What this does is if you want to change the length of your column or the diameter of your column or your film thickness, you can use this table to keep the same retention times. So if you use this calculation and find on this table similar phase ratio results, you can change your column and still not change your method because your retention time should be very close to being the same. So what I want you to take away from this is that consumables can have a great impact upon your analysis. The choice of what you use can give you lower detection limits, better peak shapes, better reproducibility, and shorter run times or better resolution depending upon what you're looking at. So make sure that when you're creating your methods, you think about the consumables up front and how that might affect what you're doing. We have a chromatography resource online that has over 100 GC application notes. You can cross-reference columns and other materials. We have troubleshooting tips, a technical library that contains posters and presentations. The email or the address is www.thermo.com/columns for the columns and CRC for the rest of the consumables. We also have a technical support line where you can get help. Someone will get back to you within 24 hours to answer your questions, which is always a good thing because when you get stuck and you're not sure, it's nice to have somebody call to help. And we'd like to thank Crawford Scientific for some of the content in this presentation.